Alright, cosmic voyagers, welcome back to our little pocket of the universe, our shared sanctuary for the mind, drifting softly as it does through the quiet velvet of space. Settle in now. Let the day's accumulated static, those persistent little hums of worry that cling like cosmic dust, just discharge. Let them fade into the background hum of the universe itself, which, believe me, has far bigger things to hum about. Tonight, we're embarking on a rather special journey, a little jaunt to visit a neighbor. A very, very close neighbor, cosmically speaking. She's often called Earth's twin, sometimes even our sister planet. And from a distance, oh, she is an undeniable stunner. Shrouded in these thick, gorgeous, almost opalescent clouds, reflecting the sunlight with a brilliance that outshines almost everything else in our night sky. You've surely seen her, a dazzling point of light hanging in the twilight, sometimes the first star you glimpse as evening descends, the evening star. Or perhaps you've caught her holding court in the pre-dawn glow, the morning star. So serene from here. So deceptively inviting. But here's the thing about family, isn't it? Especially sisters, if you're lucky or perhaps unlucky enough to have one. They can be, well, let's just say, complex is often the kindest adjective. And Venus? Oh, Venus is the sister who greets you with a dazzling smile that could melt glaciers, all while simultaneously and quite methodically plotting how to turn your favorite armchair into a pile of smoldering ash, and your entire bedroom into a high-pressure, superheated, acid-infused sauna from which there is no escape. She's not so much Earth's gentle, understanding twin as she is Earth's spectacularly dysfunctional, evil twin from a particularly dark and long-running cosmic soap opera. The one who inherited all the breathtaking celestial beauty but perhaps misplaced the instruction manual for emotional stability and, shall we say, basic hospitality. Tonight we're going to get to know her. Intimately. And by intimately, I mean we're going to explore, from the very safe and comfortable distance of your imagination, precisely why you wouldn't want to get within a few million or even tens of millions of miles of her without some very, very serious existential therapy beforehand, and an even more robust, nigh-indestructible spacecraft. Think of this as a cosmic intervention, performed with the utmost care and a healthy dose of morbid curiosity, from a vantage point where her peculiarities can't quite reach us. We're peeling back that beautiful cloudy veil, that shimmering celestial negligee, to glimpse the character-building, strong-willed, or to put it more bluntly, the utterly nightmarish personality that lurks beneath. It's a journey into a world that went spectacularly, magnificently, and quite fascinatingly wrong. A world that whispers a stark warning across the interplanetary void. And somehow, in understanding her fiery little secrets, her grand atmospheric tantrums, her crushing geological bad moods, we might just find a new, profound appreciation for our own comparatively placid, wonderfully temperate, and blessedly breathable little blue-green marble. And maybe, just maybe, in contemplating this cosmic cautionary tale, we can lull ourselves into a state of deep relaxation. A relaxation perhaps born of sheer, unadulterated relief that we are here and not there. So take a slow, deep breath in. Feel the cool air fill your lungs, a simple act Venus would view as an outrageous luxury. And as you breathe out, let go of any lingering tension, any thought that doesn't serve your peace. And let's drift, not in a rickety spaceship, but in the boundless vessel of our minds, towards our radiant, enigmatic, and profoundly twisted sister, Venus. For centuries she fooled us. She really did. Looking up from Earth, she's this beacon of steady, silvery light. No twinkling like the distant stars, because she's close, reflecting sunlight with an almost serene confidence. Early astronomers, poets, lovers, they all projected their dreams onto her. Goddess of love and beauty, right? It's a classic case of judging a book by its incredibly alluring but ultimately misleading cover. If Venus were a person at a party, she'd be the one everyone is drawn to, utterly captivating, until she opens her mouth and casually mentions her hobbies include spontaneous combustion and dissolving her guests in acid. You'd edge away slowly, wouldn't you? Smiling politely. The twin label isn't entirely without merit, mind you. Venus is, in many superficial ways, quite similar to Earth. She's roughly the same size, only a smidge smaller. She has a similar density, meaning she's made of roughly the same rocky stuff. She's our next-door neighbor in the solar system, orbiting just a little closer to the sun than we do. For a long time, scientists, being the incurable optimists they sometimes are, before the data slaps them in the face, Imagine Venus beneath those clouds. Perhaps it was a warm, tropical paradise, a swampy jungle world teeming with exotic life, like a planetary-scale version of Earth's Carboniferous period. Lush, steamy, full of giant ferns and perhaps even more giant, entirely hypothetical Venusian dragonflies. It was a lovely thought. Romantic even. It was also, as we eventually discovered, spectacularly, hilariously, tragically wrong. That beautiful opaque blanket of clouds isn't hiding a tropical wonderland. It's hiding a special kind of hell. A bespoke, artisanally crafted inferno. The kind of place you wouldn't even send your worst enemy, unless you were feeling particularly creative in your malevolence. Her personality isn't just intense, it's more like actively homicidal towards all known forms of carbon-based life. She's not just playing hard to get, she's built a fortress of unthinkably extreme conditions, a planetary keep-out sign written in letters of fire and crushing force. Her idea of a warm welcome involves atmospheric pressures that would make a deep-sea submersible implode like a cheap plastic bottle, and surface temperatures that ensure lead flows like water, and any visiting spacecraft has the lifespan of a snowflake in a blast furnace. Makes that awkward family dinner seem positively tranquil, doesn't it? So, as we begin to drift closer, let your mind relax into this image of deceptive beauty. Picture that gleaming sphere hanging in the blackness of space. So perfect, so bright. And just hold that image, alongside the gentle whispered truth of what it conceals. There's a strange comfort, isn't there, in knowing the worst from a safe distance? In contemplating a cosmic drama so extreme, it makes our own earthly concerns feel, well, a little smaller, a little less significant. And in that insignificance, perhaps, a little easier to release, as we prepare to peer beneath her pearly, poisonous veil. We glide closer now through the silent, indifferent vacuum of space, our imaginary vessel making no sound, our minds the only passengers. The sun is a fiercer, more brilliant presence here, so close to Venus, but we are shielded, safe in our mental cocoon. Venus herself looms larger, a magnificent creamy yellow globe, marbled with subtle swirls and streaks. Those clouds, they are truly something to behold. They cover the entire planet in an unbroken, impenetrable layer. Not a glimpse of the surface below. It's like approaching a world perpetually shrouded in the densest, most luminous fog you can imagine. A pearly, ethereal veil that whispers of mysteries, of hidden landscapes, of secrets kept for eons. It's easy to see why early science fiction writers let their imaginations run wild. A world entirely hidden from view? The possibilities seemed endless. Steaming jungles, vast oceans, perhaps even sophisticated civilizations thriving beneath that cloudy canopy, blissfully unaware of our prying eyes. The clouds themselves seemed almost inviting, like cosmic meringue, fluffy and soft. You can almost imagine diving into them, a gentle, billowy descent into an unknown world. A comforting thought, isn't it? Like sinking into a celestial feather bed. Except, well, this is Venus we're talking about. And on Venus, comforting is a word that has long since packed its bags and fled the planet, screaming. Those beautiful, opaque clouds, the ones that give Venus its mesmerizing, almost angelic glow? They are not made of water vapor, like the fluffy white clouds of Earth that drift lazily across a summer sky, promising gentle rain or welcome shade. Oh no, that would be far too pleasant, too pedestrian for our dramatic sister. The clouds of Venus are predominantly composed of something with a bit more bite. Tiny droplets, yes, but not of water. These are droplets of sulfuric acid. Yes, you heard that right. Sulfuric acid. The same kind of highly corrosive substance you might find in a car battery, the kind that would merrily eat through your clothes, your skin, and pretty much anything else it fancies. These aren't just wispy little traces of acid, mind you. We're talking vast, planet-spanning banks of the stuff miles and miles thick. Imagine a global, eternal chemical spill, suspended in the sky. It's a corrosive welcome mat, unfurled with a certain malevolent flourish. So, that gentle, billowy descent we were just imagining? Picture it now. Your ship, or more uncomfortably, your spacesuit self, begins to enter the upper layers. At first, it might just seem like a thick, yellowish fog. But then, the instruments would start to scream. The outer layers of your vessel would begin to pit, to discolor, to literally dissolve. Any exposed surfaces would be under immediate, relentless chemical assault. It's not so much a dive into a feather bed as it is a plunge into a planetary-scale vat of industrial-strength drain cleaner. Relaxing, isn't it? The universe certainly has a dark sense of humor. These acid clouds are not a static feature either. They are whipped around the planet by ferocious winds in the upper atmosphere, racing at speeds of over 200 miles per hour. So, it's not just acid, it's acid in a high-speed blender, a perpetual global acid storm. This superrotation, as it's called, means the cloud tops circumnavigate the entire planet in about 4 Earth days, far faster than the planet itself rotates. We'll get to that leisurely, almost comatose rotation later. It's another of Venus's charming eccentricities. And these clouds are thick, incredibly thick. They extend from an altitude of about 28 miles, 45 kilometers, up to nearly 43 miles, 70 kilometers. That's a 15-mile thick layer of corrosive mist. Sunlight struggles to penetrate this dense, acidic shroud. Only a fraction of the light that bathes the cloud tops actually makes it down to the surface. And the light that does get through is filtered, diffused, cast into a perpetual, gloomy, orange-tinged twilight. So, even if you could somehow survive the acid, you'd be wandering around in a dim, oppressive, sepia-toned world, like an old, faded photograph of a terrible place. Cheerful. It's a stark reminder, isn't it? How appearances can be so profoundly deceiving. From Earth, Venus is a jewel. Up close, those jewels are revealed to be glittering droplets of pure, unadulterated chemical hostility. It's a common theme in the universe, this juxtaposition of beauty and lethality. A nebula can be a breathtaking canvas of cosmic color, and also a fiercely irradiating nursery of stillborn stars. A galaxy can spiral with unimaginable grace, while its central black hole casually devours suns. Venus just wears its particular brand of beautiful treachery a little more, personally. Like a femme fatale in a cosmic noir film, her beauty is the lure, and the danger is the point. So, as you lie there, feeling the gentle fabric of your blanket, the soft support of your pillow, perhaps take a moment to appreciate the simple, non-corrosive nature of your immediate environment. No sulfuric acid rain forecast for your bedroom tonight, I trust. No need to check if your pajamas are acid-proof. It's these little comforts, these everyday non-horrors that Venus, in her magnificent terribleness, can help us appreciate anew. Let your mind drift through those imagined clouds from a safe distance, of course. See their pearly sheen, the way they catch the distant sunlight. And then, with a little mental squint, see the truth of them, the tiny vicious droplets. Hold both images, the beauty and the menace, the allure and the acid. It's a strange kind of lullaby, this cosmic dance of appearances and reality. A reminder that even the most uninviting truths, when viewed from the right perspective, can be strangely fascinating. And as we float onwards, deeper into Venus's embrace, prepare yourself. Because the welcome is about to get considerably more crushing. Having navigated the gentle yet utterly corrosive caress of Venus's upper cloud decks, in our minds, of course, where acid has no sting and dissolution is merely a poetic concept, we now begin our descent. Slowly, carefully, we drift downwards, through those endless layers of sulfuric mist. The gloom deepens, the sunlight fading from a weak orange glow to an even more oppressive, murky twilight. The temperature, which was surprisingly Earth-like and even a little chilly way up in the very highest cloud tops, is beginning to climb. Steadily, ominously. But it's not the heat that will try to kill you first down here. Oh no, Venus is more creative than that. She likes to layer her discomforts, like a malevolent cosmic pastry chef. As we sink further below the main cloud base, say to an altitude of around 30 miles, the atmosphere around us, while still hazy, begins to clear a little, relatively speaking. We're still bathed in that dim orange light, but the main problem here isn't visibility. It's the sheer, unadulterated weight of the air itself. The atmospheric pressure. On Earth, at sea level, we experience about 14.7 pounds per square inch of pressure. It's the weight of the miles of air stacked above us, pressing down. We're so used to it we don't even notice it. Our bodies are perfectly adapted, pushing out with an equal force. It's a comfortable equilibrium. Like a gentle atmospheric hug we've had since birth. Venus, however, does not do gentle hugs. Venus does boa constrictor death squeezes. As we descend through her atmosphere, the pressure mounts, and mounts, and mounts, relentlessly. By the time we reach the surface of Venus, the atmospheric pressure is over 90 times that of Earth. 90 times. Let that sink in. That's the equivalent of being nearly a kilometer, or about 3,000 feet, deep in Earth's oceans. Imagine the crushing weight of that much water. Now imagine that same pressure, but it's not water. It's air. Hot, dense, incredibly hostile air. To try and visualize this, picture a standard, fairly robust submarine. The kind designed to explore the deep ocean. If you were to magically transport that submarine to the surface of Venus, it would crumple. It would implode like you stepped on an empty soda can. Well, that's what over 90 atmospheres of pressure does to things not specifically built to withstand it. And by specifically built, I mean built like a heavily armored bank vault designed by a particularly paranoid tank engineer. So, what would that feel like for you if you were somehow inexplicably standing on the surface of Venus without the universe's most advanced and probably still inadequate pressure suit? Well, you wouldn't be standing for long. You wouldn't even have time to register the spectacular awfulness of your surroundings. The sheer weight of the Venusian atmosphere would crush you instantaneously. Your body, so perfectly adapted to Earth's gentle caress, would simply collapse. It's not a pleasant thought, I know, but it's the reality of this place. It's the kind of welcome Venus extends to unprotected organic matter. Quick, efficient, and decidedly final. It's a strange concept, air being that heavy, that forceful. We think of air as, well, air. Light, ethereal, mostly nothing. But on Venus, the atmosphere is so incredibly dense, it's almost like a fluid. If you could somehow wave your arm, a big if given the crushing, you'd feel a resistance far more than you do on Earth. It would be like trying to wade through incredibly thick, hot soup. A soup that also wants to dissolve you and cook you simultaneously, but we're focusing on the pressure for now. One horror at a time, please. This immense pressure is primarily due to the composition of the atmosphere itself. It's about 96.5% carbon dioxide. That's an almost unimaginably thick blanket of CO2. On Earth, carbon dioxide is a trace gas, measured in parts per million. We worry about it increasing from 0.03% to 0.04% because of its greenhouse effects. Venus has taken that concept and run with it to an almost psychotic extreme. 96.5%. It's less an atmosphere with some CO2 in it, and more a planet drowning in a pure planetary ocean of the stuff. This massive amount of CO2 is what gives the atmosphere its incredible density and, therefore, its crushing weight. It's another of Venus's little surprises. You might expect the danger to come from something exotic, something alien. But no, it's good old carbon dioxide, a gas we breathe out with every breath, a gas plants adore. Just in quantities that have gone utterly, catastrophically overboard. It's a lesson in moderation, perhaps. A cosmic reminder that too much of even a familiar thing can be problematic. Especially when too much means an atmosphere dense enough to turn you into a human pancake. So, as you lie there, feeling the air around you so light, so unnoticeable, perhaps offer a silent thank you to Earth's atmosphere. It's doing a remarkable job of not crushing you. It's giving you that gentle 14.7 pounds per square inch hug, and not the Venusian welcome to the hydraulic press experience. There's a certain peace in appreciating these fundamental safeties, isn't there? The things we take so utterly for granted. Let your body feel heavy sinking into your bed. But it's a comfortable heaviness. A yielding to gravity, not a submission to overwhelming, bone-shattering pressure. Allow the thought of that crushing Venusian embrace to simply highlight the gentle support beneath you now. Paradoxically, contemplating such an extreme environment can make your current comfort feel even more profound, more secure. The mind is a funny thing, isn't it? It can find relaxation even in the contemplation of cosmic horrors, as long as they stay safely out there. And we, my friends, are safely here, drifting, observing, and getting ready to feel the heat. Because Venus isn't just a pressure cooker. It's also an oven. Having mentally survived the rather enthusiastic welcome of Venus's atmospheric pressure, a pressure that would, in reality, have turned us into a rather unappetizing geological feature in nanoseconds, we continue our exploration of this charmingly hostile world. We are, in our imaginations, now standing on the surface, or at least hovering just above it, still safely cocooned from the, well, everything. The dim, orange, sulfur-filtered sunlight casts an eerie, permanent twilight over a landscape we can't quite make out yet, shrouded as it is in the dense, hazy lower atmosphere. But it's not the gloom, or even the lingering scent of brimstone and regret, that commands our immediate attention. It's the heat. Oh, the staggering, relentless, all-encompassing heat. If Venus's atmospheric pressure is like being at the bottom of a deep ocean, then its surface temperature is like being in a very efficiently run, self-cleaning pizza oven. A very large, planetary-scale pizza oven that has been left on its highest setting for the last few billion years, with the door firmly, irrevocably jammed shut. The average surface temperature on Venus is a scorching 464 degrees Celsius. That's around 867 degrees Fahrenheit. Let's put that into perspective, shall we? Water, as we know, boils at 100 degrees Celsius, 212 Fahrenheit, at Earth's sea level. So Venus is over 4.5 times hotter than boiling water. Your kitchen oven, when you're baking a cake or roasting a chicken, might go up to, say, 200 or 250 degrees Celsius, around 400 to 480 Fahrenheit. Venus is hotter than your oven on its most ambitious setting, significantly hotter. In fact, it's so hot on the surface of Venus that lead would be a liquid. Yes, the heavy, dense metal lead, which melts at 327.5 degrees Celsius, 621.5 Fahrenheit, would exist on Venus not as solid ingots, but as shimmering puddles, perhaps even little rivulets of molten metal if the terrain allowed. Imagine a world where lead flows like water. It's a rather Dali-esque image, isn't it? Clocks might not be melting, but your lead pipes certainly would be. Not that you'd have lead pipes, or any pipes, or a house, or indeed a corporeal form. This extreme heat isn't just a localized phenomenon, a particularly fiery hotspot. It's global. From the equator to the poles, from the lowest plains to the tops of the highest Venusian mountains, and yes, Venus has mountains, quite impressive ones, we'll get to them, the temperature is remarkably uniform. There's no escaping it. No cool polar regions to offer respite. No refreshing nighttime dip in temperature. Venus is consistently, comprehensively, and utterly infernal day and night, pole to pole. The thick, dense atmosphere is very good at distributing that heat, ensuring that every square inch of the planet is equally democratically baked to a crisp. Think about what that means for any possibility of life as we know it. Complex organic molecules, the building blocks of life, simply fall apart at these kinds of temperatures. They denature, they cook, they cease to be complex. Water, essential for life as we understand it, cannot exist as a liquid on the surface of Venus. It would have boiled away eons ago, assuming it was ever there in significant quantities to begin with. Any visiting astronaut, even in the most advanced, theoretically heat-proof suit imaginable, would be in dire straits. The challenge wouldn't just be insulation, it would be actively shedding the immense heat soaking in from every direction. It's like trying to keep an ice cube frozen while holding it inside a working blast furnace. Good luck with that. This isn't the kind of heat that gives you a pleasant tan. This is the kind of heat that sterilizes. The kind of heat that transforms geology. The kind of heat that makes even the hardiest extremophile bacteria on Earth look like delicate, pampered snowflakes. If there's life on Venus, it's not playing by any rulebook we currently understand. It would have to be made of, well, something else entirely. Something that finds 867 degrees Fahrenheit a bit chilly, perhaps. The universe is vast and its capacity for surprise is endless, but finding life frolicking in Venus's surface conditions would certainly be a headline grabber, and probably require a whole new branch of biology and perhaps theology. The sheer, unyielding nature of this heat is a testament to the power of atmospheric effects, which we'll delve into more deeply soon. It's not primarily because Venus is closer to the Sun than Earth. Mercury is much closer to the Sun, yet its average surface temperature is actually lower than Venus's, although Mercury experiences much wilder temperature swings between its sun-facing and dark sides due to its lack of a significant atmosphere. Venus, with its thick atmospheric blanket, traps the Sun's energy with ruthless efficiency, creating this stable, global, superheated state. She's essentially wrapped herself in an ultra-thermal, heat-hoarding, planetary-scale snuggie of doom. So, as you lie there, perhaps feeling a little warm under your covers or maybe a little cool, appreciate the subtle art of thermoregulation your body and your home are performing. Appreciate the thermostat, the open window, the fan, the simple act of kicking off a blanket. These are luxuries Venus has never known. She is committed to her heat. Utterly, terrifyingly committed. Let the thought of that immense, lead-melting temperature not cause you discomfort, but rather, enhance your appreciation for the delicate, life-sustaining balance here on Earth. Feel the gentle, normal temperature of the air on your skin. It's not trying to incinerate you. It's not trying to turn your constituent metals into puddles. It's just there, supporting you, allowing you to exist. Venus, our fiery sister, offers us this strange gift, the gift of perspective. By showing us the extreme, she helps us see the preciousness of the mean, the beauty of the balanced. And in that recognition, there's a quiet kind of peace to be found. A peace born not of ignorance, but of understanding the sheer, improbable luck of our own terrestrial comfort. Now, let's consider the air itself, the very stuff that holds all this delightful heat. We've felt the crushing weight of Venus's embrace. We've basked in the imaginary glow of its lead-melting surface temperatures. And now, let's turn our attention to the very air itself, or rather, the not really air as you know it, that makes up this delightful planet-sized pressure cooker. We've already touched on its star ingredient, carbon dioxide, in quantities that would make a climate scientist weep, but it's worth dwelling on this atmospheric marvel a little longer, because it truly is the architect of Venus's unique brand of misery. Imagine standing on the Venusian surface, hypothetically of course, because as we've established, standing would be a very brief and terminal activity. You try to take a breath, a natural, instinctive human action. On Earth, this simple act fills your lungs with a life-sustaining mixture, predominantly nitrogen, with a generous and vital helping of about 21% oxygen. That oxygen is the key, the fuel for our cells, the spark that keeps our internal engines running. On Venus, attempting to take a breath would be inadvisable and spectacularly ineffective. The atmosphere, as we mentioned, is about 96.5% carbon dioxide. CO2, the stuff we exhale, the stuff plants absorb. In small quantities, harmless. In the quantities present on Venus, it's a suffocating blanket, a planetary asphyxiant. There's virtually no free oxygen to be found. Less than 0.002%. To call it a trace amount would be an overstatement. It's more like a statistical error, a cosmic rounding afterthought. So, that first instinctive gasp on Venus? It wouldn't bring life. It would bring a lungful of hot, incredibly dense and utterly unbreathable CO2. Your body, expecting oxygen, would find none. The alarms in your brain would be screaming. But it wouldn't just be the lack of oxygen that gets you. Carbon dioxide at very high concentrations is itself toxic. It would interfere directly with your body's ability to regulate breathing and blood chemistry. Even if there were oxygen, the sheer overwhelming presence of CO2 would be a profound physiological shock. It's like being trapped in a room where all the air has been replaced by the exhaust fumes of a colossal planetary-scale engine that's been running for billions of years. Not a pleasant thought. It gives a whole new meaning to the phrase, a breath of fresh air, doesn't it? Suddenly, the air in your room, even if it's a bit stuffy, even if the cat just walked through, feels like the sweetest, most precious elixir. Beyond the dominant carbon dioxide, there's about 3.5% nitrogen. Nitrogen is mostly inert, it's the main component of Earth's atmosphere too, so that's not the problem. But then there are the other, more characterful, trace elements. We've already discussed the delightful sulfuric acid clouds, but even in the lower atmosphere there are traces of sulfur dioxide, argon, and even a whisper of water vapor. But so little, it's practically a cruel joke in such a superheated environment. Enough to contribute to the chemistry, but not enough to, say, form a puddle, or a cloud that isn't actively trying to dissolve you. This thick, CO2-rich atmosphere is not just unbreathable and crushing. It's also the primary reason Venus is so infernally hot. This is where we meet the runaway greenhouse effect, in its most dramatic and terrifying form. On Earth, greenhouse gases like CO2, methane, and water vapor play a vital role. They trap some of the sun's heat, keeping our planet warm enough for liquid water and life. It's a delicate balance. A planetary thermostat. Venus shows us what happens when that thermostat breaks. And not just breaks, but gets stuck on full blast, and then has the knob superglued in place. Sunlight, mostly visible light, penetrates the upper atmosphere in clouds, and some of it reaches the surface, warming it up. The warmed surface then tries to radiate that heat back out into space, mostly as infrared radiation. On Earth, some of this infrared is trapped by our modest blanket of greenhouse gases, keeping us cozy. The rest escapes. On Venus, however, that staggeringly thick blanket of 96.5% carbon dioxide is incredibly opaque to infrared radiation. It's like a one-way mirror for heat. The sunlight gets in, but the heat radiation trying to get out is trapped. And trapped. And trapped. So the temperature just keeps rising. More heat is trapped than can escape, and the planet cooks. It's a vicious cycle. The hotter it gets, the more certain compounds might outgas from the rocks, potentially adding even more greenhouse gases to the atmosphere. Though Venus is so far gone, it's hard to make it much worse. This is the runaway part. It's a positive feedback loop from hell, literally. It's thought that Venus might have once had more water, perhaps even oceans, billions of years ago. But being closer to the sun, it was warmer. As water evaporated, it would have acted as a powerful greenhouse gas, raising temperatures further. This could have led to more evaporation, more warming, until the oceans boiled away entirely. The water vapor in the upper atmosphere would then have been broken apart by ultraviolet radiation from the sun, with the light hydrogen atoms escaping into space, and the oxygen potentially reacting with rocks or other gases, leaving behind a dry, superheated, CO2-drenched horror show. A planet that essentially boiled itself to death and then wrapped itself in a permanent shroud of its own toxic exhalations. Makes you think, doesn't it? About the delicate atmospheric balance here on Earth. About the thin blue line of our own atmosphere, working so diligently, so thanklessly, to keep us from becoming, well, Venus. It's a sobering thought, but also in its own stark way, a deeply relaxing one. Because right now, in this moment, you are breathing air that sustains you. Air that is not trying to crush you, cook you, or suffocate you. Air that is, in its own quiet way, a miracle. So, take another slow, conscious breath. Feel the coolness of the inhale, the gentle release of the exhale. This simple act is a profound connection to the life-giving systems of our own world. And as you do, let the image of Venus's atmosphere, that thick CO2 duvet of no comfort, simply drift by. A reminder of how fortunate we are to be here breathing easy on this pale blue dot. And as we continue our imaginary sojourn, let's prepare for some weather. Because even in hell, apparently, it can rain. We've acclimated, in our uniquely detached and imaginary way, to the crushing pressure, the infernal heat, and the suffocating composition of Venus's atmosphere. One might think that's quite enough environmental unpleasantness for one planet. Surely there can't be more? Oh, but this is Venus, our overachieving sister in all things hostile. She always has another little surprise, another layer of nope, to add to the experience. And that, my friends, brings us to the weather. Specifically the rain. Now, on Earth, rain can be a mixed blessing. A gentle shower can be refreshing, life-giving, a soothing sound on a tin roof that lulls you to sleep. A torrential downpour can cause floods and disruption. But generally, Earth rain is made of, well, water. H2O, the stuff of life. Even acid rain on Earth, a serious environmental concern caused by pollution, is still primarily water, just with some unwelcome acidic compounds mixed in. Venus, true to form, scoffs at such tame precipitation. When it rains on Venus, it doesn't rain water. We've established there's no liquid water on the surface, and precious little water vapor anywhere in that inferno. No, Venusian rain is something far more in keeping with the planet's overall charming personality. It rains sulfuric acid. Remember those lovely, pearly clouds we discussed earlier, the ones made of concentrated sulfuric acid droplets, miles thick, swirling high above? Well, under certain conditions, those droplets can coalesce, grow heavy enough to begin falling. Just like water droplets do in Earth's clouds. So you get precipitation. Streaks of it, known as virga, have been observed falling from the underside of the Venusian cloud deck. Virga is rain that evaporates before it reaches the ground. And on Venus, that's precisely what this sulfuric acid rain does. It begins its descent from the cooler, higher altitudes of the cloud layers. Droplets of pure, unadulterated H2SO4. Imagine a gentle shower of car battery acid. Not exactly something you'd want to dance in, is it? But here's where Venus adds another of her characteristic little twists, a sort of meteorological practical joke. As these acid raindrops fall towards the surface, they encounter the increasingly hellish temperatures of the lower atmosphere. Remember, the surface is around 464 degrees Celsius, 867 Fahrenheit. Sulfuric acid, for all its corrosive power, actually boils at a much lower temperature than that, around 337 degrees Celsius, 639 Fahrenheit, though it depends on concentration and pressure. So, as these acid raindrops descend into the furnace-like lower atmosphere, they reach a point, still miles above the actual surface, where the ambient temperature is higher than their boiling point. And what happens when a liquid reaches its boiling point? It turns back into a gas. So, the sulfuric acid rain of Venus never actually reaches the ground. It falls, a corrosive shower, for miles and miles, only to boil away in the scorching heat of the lower atmosphere, turning back into sulfur dioxide and water vapor, which then, presumably, gets recycled back up to form more acid clouds, a delightful, self-sustaining cycle of chemical unpleasantness. It's a phantom rain. A rain of pure terror that never quite makes it. Imagine standing on the surface, again purely hypothetically, please don't try this at home or on Venus, looking up into that dim, orange, oppressive sky. You might, if you could see through the haze, perceive these dark streaks falling from the distant cloud base, a promise of something. But it would never arrive. Just the thought of it though. Acid rain, falling, then vaporizing into an even hotter, more noxious gas before it can even offer the slightest, most fleeting, most unwelcome sensation of wetness. It's almost poetic in its utter futility and menace. The universe, in its infinite and often deeply weird wisdom, has created a planet where it rains acid that boils before it hits the ground. It's the kind of detail that makes you wonder if the cosmos has a rather dry, slightly sadistic sense of humor. Oh, you thought the heat and pressure were bad? How about some acid rain? It's boiling acid rain that doesn't even have the decency to properly land. This phantom rain, this virga of sulfuric acid, contributes to the overall chemical soup of the lower atmosphere. The sulfur compounds are a key part of Venus's charming environment. They contribute to the smell, if you could smell it and survive, which you couldn't. Think rotten eggs mixed with a chemical fire. They contribute to the color of the sky, and they contribute, of course, to the general air of, please don't touch anything, ever. It's another of those stark contrasts, isn't it? The idea of rain, which on Earth is so often associated with renewal, with cleansing, with life, is twisted on Venus into something sterile, corrosive, and ultimately illusory. It's a beautiful, awful, perfect metaphor for the planet itself. A promise of something familiar, horrifically transformed. So, as you lie there, perhaps listening to the gentle sound of actual non-acidic rain outside your window, or maybe just the quiet hum of your own home, take a moment to appreciate the simple, non-threatening nature of earthly precipitation. Our clouds weep water, not battery acid. Our showers refresh, they don't dissolve and then boil away in midair. It's these little things, these grand cosmic comparisons, that can bring a strange sense of comfort. The thought of that Venusian acid rain falling endlessly, never arriving, a perpetual chemical torment in the skies of a lost world. Let it just be a story. A bizarre little footnote in the grand, sprawling narrative of the cosmos. A story that, by its very extremity, makes our own world seem all the more precious, all the more peaceful. And as that thought settles, let your mind drift, serene and untouched, knowing that here at least the rain is just rain. And now, let's consider how Venus got herself into this rather unfortunate state. We've danced with acid rain that never lands, breathed imaginary air that suffocates, and felt the phantom crush of an atmosphere heavy enough to flatten a submarine. We've even contemplated what it might be like to melt lead with ambient room temperature. So the big question arises, how? How did Earth's supposed twin, a planet so similar in size and composition, end up as this planetary scale cautionary tale? How did Venus turn itself into an oven, a pressure cooker, a chemical waste dump, all rolled into one rather inhospitable celestial body? The answer, my friends, lies in a process that sounds almost mundane until you see it in its most extreme runaway form, the greenhouse effect. On Earth, as we've touched upon, the greenhouse effect is a good thing, a vital thing. Our atmosphere, with its delicate balance of gases like water vapor, carbon dioxide, and methane, acts like a thin, transparent blanket. It lets sunlight in to warm the surface, and then it traps just enough of the outgoing heat to keep our planet at a comfortable, life-sustaining average temperature of around 15 degrees Celsius, 59 Fahrenheit. Without this natural greenhouse effect, Earth's average temperature would be a frigid minus 18 degrees Celsius, around 0 Fahrenheit. We'd be an ice ball. So, thank you, greenhouse effect. You're doing a stellar job here. In moderation. Venus is what happens when moderation checks out, leaves the solar system, and never sends a postcard. Venus is the greenhouse effect on an overdose of cosmic steroids, followed by a planet-sized energy drink and a dare. It's the runaway greenhouse effect. Imagine, if you will, early Venus, billions of years ago. Perhaps it was a little warmer than Earth, being closer to the sun. Perhaps it had oceans of liquid water. As the sun's energy beat down, this water would have evaporated, forming water vapor in the atmosphere. Now, water vapor is a very effective greenhouse gas. So, more water vapor in the atmosphere meant more trapped heat, which meant the planet got warmer. A warmer planet meant more water evaporation. More evaporation meant more water vapor. More water vapor meant, well, you see the loop. A positive feedback cycle. The planet starts to warm itself up. On Earth, we have mechanisms that help regulate this. We have plate tectonics, for instance, which over geological timescales can bury carbon, removing CO2 from the atmosphere. We have vast oceans that can absorb CO2. We have life, which photosynthesizes, pulling CO2 out of the air. Earth has a complex system of checks and balances, a planetary immune system, if you like, that has, so far, kept our greenhouse effect from going rogue. Venus, it seems, lacked these robust regulatory mechanisms, or they were overwhelmed. As it got hotter and hotter, any oceans it might have had would have eventually boiled away completely. All that water, now as vapor in the atmosphere, would have dramatically amplified the greenhouse heating. Then another unfortunate thing happens. High up in the atmosphere, intense ultraviolet radiation from the sun would have zapped these water molecules, H2O, breaking them apart into their constituent hydrogen and oxygen atoms. Hydrogen, being the lightest element, would have then gracefully and rather permanently escaped into space. Sayonara, hydrogen. With the hydrogen gone, there's no way to reform water. The oxygen left behind might have reacted with carbon on the surface to form more carbon dioxide, or combined with other minerals in the rocks. The net result, water, the potential coolant and solvent for life, was lost forever. And in its place, a colossal buildup of carbon dioxide. Where did all that CO2 come from? Well, like Earth, Venus is a rocky planet, and it's thought to have had extensive volcanic activity throughout its history. Volcanoes on Earth release CO2. On Earth, much of this CO2 dissolves in the oceans and eventually gets incorporated into carbonate rocks like limestone. It's a long-term storage solution for carbon. But if Venus lost its oceans early on or never had them in the same way Earth did, then there was no efficient mechanism to scrub all that volcanic CO2 from the atmosphere. So it just accumulated, and accumulated, and accumulated, for billions of years. The result is what we see today, an atmosphere that is 96.5% carbon dioxide, creating that crushing pressure and, crucially, that incredibly potent runaway greenhouse effect. It's a suffocating, heat-trapping blanket of epic proportions. The planet became a pressure cooker with a lid welded shut, and the heat just kept building and building until it reached the stable, infernal equilibrium we observe today, where the surface temperature hovers around that lead-melting 464 degrees Celsius. It's a stark illustration of how planetary evolution can diverge dramatically, even for worlds that start out with similar vital statistics. A few key differences in initial conditions: distance from the star, geological activity, or atmospheric loss processes, and you can end up with Earth, a vibrant, life-filled paradise on the one hand, and Venus, a sterile, superheated hell's cape on the other. Siblings, yes, but one clearly got the better cosmic inheritance, or at least made better planetary life choices. It's a cautionary tale, too, whispered across the interplanetary void. It reminds us that planetary climates are not necessarily stable forever. They can change, sometimes catastrophically. While Earth is not currently on a trajectory to become Venus, our atmosphere is very different and we're further from the sun. The story of Venus underscores the profound importance of understanding atmospheric dynamics and the greenhouse effect on our own world. It's a cosmic nudge to pay attention to the subtle shifts in our own delicate atmospheric balance. A reminder that planets can indeed go wrong. So, as you lie there, feeling the stable temperature of your room, the gentle pressure of Earth's well-behaved atmosphere, perhaps spare a thought for Venus, the planet that cooked itself. Let the story of its runaway greenhouse effect not be a source of anxiety, but a source of wonder at the sheer power of planetary processes, and a source of quiet gratitude for the intricate, life-sustaining systems that keep Earth so un-Venus-like. It's a deep, cosmic sigh of relief, really. And in that relief there is a path to peace, a path to sleep. The universe provides its lessons in the most dramatic and sometimes most terrifying ways. But even in the story of a planetary catastrophe, there's a strange, detached beauty to be found in the understanding of it. And now, let's consider how time itself behaves on this most unusual of worlds. We've waded through Venus's atmospheric soup, felt its scorching breath, and even pondered its phantom acid rain. We've delved into the dramatic climatic history that sculpted this planetary inferno. Now, let's turn our attention to something perhaps a little less immediately lethal, but no less bizarre and unsettling: the way Venus experiences time. Or, more precisely, the peculiar relationship between its day and its year. It's another of those Venusian quirks that seems almost designed to make you tilt your head and say, wait, what? On Earth, our relationship with time is fairly straightforward, cosmically speaking. Our planet spins on its axis once roughly every 24 hours, giving us our familiar cycle of day and night. And it orbits the sun roughly every 365.25 days, giving us our year. A day is much, much shorter than a year. This is standard. This is sensible. This is how most well-adjusted planets in the solar system operate. Venus, of course, scoffs at sensible. Venus has to be different. Venus has to be extra. A Venusian year, the time it takes for Venus to complete one orbit around the sun, is about 225 Earth days. So its year is actually shorter than Earth's year. Being closer to the sun, it zips around on its orbital track a bit more quickly. Fair enough. No great cosmic scandal there. But then we come to the Venusian day, the sidereal rotation period of Venus. The time it takes for the planet to spin once on its axis relative to the background stars is an astonishingly leisurely 243 Earth days. Yes, you read that correctly. It takes Venus 243 Earth days to complete just one rotation. Now let's put those two numbers together. Its year is 225 Earth days. Its day is 243 Earth days. This means that a day on Venus is longer than its year. Let that sink in for a moment. Imagine living on a planet where a single day stretches on for longer than the entire period it takes to go around your sun. The very concept is wonderfully, mind-bogglingly strange. It's like attending a party, the year, that finishes before you've even managed to fully turn around once, the day, to survey the room. It's like your birthday arriving before you've even gotten out of bed from the previous birthday. It gives a whole new meaning to a long day at the office. On Venus, a long day is an understatement of cosmic proportions. And to add another layer of delightful weirdness to this temporal tapestry, Venus rotates backwards. Yes, backwards. Most planets in our solar system, including Earth, rotate on their axis in a counterclockwise direction when viewed from above their north pole. This is called prograde rotation. Venus, along with Uranus, which is tipped over on its side and sort of rolls along, rotates in a clockwise direction. This is called retrograde rotation. So, on Venus, if you could somehow see the sun through those thick, eternal clouds, which you can't, but let's imagine for a moment, it would rise in the west and set in the east. Slowly. Incredibly, agonizingly slowly. Given that a full rotation takes 243 Earth days, and the planet is also orbiting the sun, the length of a solar day on Venus, the time from one sunrise to the next if you could see it, is actually about 117 Earth days. So you'd have roughly 58 Earth days of dim, gloomy, orange-filtered daylight, followed by roughly 58 Earth days of equally dim, gloomy, orange-filtered night. Assuming, of course, you could tell the difference in that oppressive, oven-like atmosphere. Imagine an entire Earth season, say summer, passing by during a single Venusian afternoon, or a single Venusian night. The very rhythms of life, if any could exist there, would be stretched and distorted almost beyond our comprehension. What would morning even mean when it lasts for the better part of 2 Earth months? How would you structure your day when it outlasts your year? The existential implications are almost comical. Wake up, it's Monday, and it will continue to be Monday for the next 58 Earth days. Enjoy your incredibly prolonged coffee break. Why this sluggish, backwards rotation? The exact reasons are still a subject of scientific debate. Perhaps it was due to a massive impact or a series of impacts, early in its history that slowed its spin and even flipped it over. Or perhaps it's the result of a complex interplay of gravitational tidal forces from the sun acting on its incredibly thick atmosphere, coupled with friction between the atmosphere and the solid planet. The Venusian atmosphere is so dense and massive, it contains nearly 100 times the mass of Earth's atmosphere. This super-rotating atmosphere, whipping around the planet much faster than the planet itself turns, could be exerting a significant drag, slowing the planet's rotation over eons. It's like the planet itself is trying to turn, but it's slogging through this incredibly thick, soupy air that's moving in a different way, creating a kind of cosmic molasses effect. Whatever the cause, the result is this bizarre temporal landscape. A planet where time itself seems to have become sluggish, almost reluctant. It adds to the overall sense of Venus being a place where things have gone profoundly, fundamentally awry. Even its heartbeat, its daily rhythm, is out of sync with the rest of the solar system's more energetic dance. So, as you lie there, perhaps aware of the steady, familiar passage of time in your own room, the tick of a clock, the distant sound of a car, the slow shift from evening to night, consider the strange, drawn-out existence on Venus. Let the thought of a day longer than a year, a sun rising in the west, not be a source of confusion, but a source of appreciation for the familiar, predictable rhythms of Earth. Our planet's spin, so reliable, so comforting in its regularity, gives us the framework for our lives. Venus offers no such comfort. Only a slow, backward, seemingly eternal grind. There's a strange sort of peace in contemplating such cosmic absurdity, isn't there? It's so far removed from our own experience, it becomes almost abstract. A curiosity that highlights the relative sanity of our own little corner of the universe. And as your own day gently draws to a close, at a perfectly reasonable, earthly pace, let that thought settle. Let the strange, slow waltz of Venus be a distant, muffled drum, while you drift to the much more soothing, familiar rhythm of your own breath, in your own time. We've explored Venus's atmosphere, its temperature, its peculiar sense of time. We've even imagined its non-existent acid rain. Now, let's consider another aspect of its environment, one that's a bit more invisible but no less critical to understanding why Venus is the way it is, and why Earth is, thankfully, not. Its relationship with the Sun, specifically concerning the solar wind and magnetic fields. Or rather, Venus's distinct lack of a significant one. On Earth, we are incredibly fortunate to be protected by a global magnetic field. Generated by the movement of molten iron in our planet's outer core, this magnetic field extends far out into space, forming a sort of invisible shield called the magnetosphere. This magnetosphere deflects the majority of the solar wind, a constant stream of charged particles, mostly electrons and protons, flowing outwards from the Sun at incredible speeds. Without our magnetosphere, this solar wind would strip away our atmosphere over geological timescales, much like it's believed to have done to Mars, which lost its global magnetic field billions of years ago. Our magnetic field also protects us from the worst effects of solar flares and coronal mass ejections, which can send powerful bursts of radiation and energetic particles hurtling our way. It's our planetary force field, our unsung hero. Venus, our twisted sister, is not so fortunate. Venus does not possess a significant, internally generated global magnetic field. It has a very weak induced magnetosphere, created by the interaction of the solar wind directly with its upper atmosphere, the ionosphere, but this is a pale imitation of Earth's robust shield. It's like comparing a sturdy castle wall to a thin silk curtain in the face of a battering ram. So what does this mean for Venus? It means that the solar wind, that relentless stream of energetic particles from the Sun, slams directly into the upper layers of Venus's atmosphere. There's no strong deflector shield to ward it off. It's like standing in a perpetual cosmic sandblaster, with the sand being tiny high-velocity charged particles. This direct interaction has had profound consequences for Venus over its long history. One of the most significant is atmospheric stripping. The solar wind, by constantly bombarding the upper atmosphere, can gradually erode it, carrying away atmospheric gases into space. Remember how we discussed Venus losing its water, with hydrogen escaping into space? The solar wind would have been a very efficient accomplice in that process, helping to sweep away those newly liberated hydrogen atoms and other lighter elements before they had a chance to recombine or settle. Even today, this process continues. Spacecraft observations have shown that the solar wind is still actively stripping away particles from Venus's ionosphere, particularly oxygen ions. It's a slow, steady erosion, like a cosmic river gradually wearing away at a stone. Over billions of years, this relentless solar wind abrasion has played a significant role in shaping the Venusian atmosphere into the dense, CO2-dominated and remarkably dry state we see today. It's a planet that's been taking a beating from the Sun, up close and personal, without proper protection for its entire existence. Imagine sunbathing, but instead of just ultraviolet light to worry about, you've got a constant barrage of high-energy protons and electrons, with no ozone layer and no magnetic field to offer even a modicum of protection. That's Venus's daily reality at the top of its atmosphere. It's another reason why any hypothetical Venusian life, especially anything complex that might be sensitive to radiation, would have an exceptionally hard time. Not only would it have to contend with the heat, pressure, and acid, but also this constant shower of solar radiation. Venus really does go all in on the inhospitable front. No half measures for our fiery twin. The lack of a strong magnetic field also means that Venus has no beautiful auroras, like Earth's aurora borealis and Australis. Auroras are created when charged particles from the solar wind are channeled by a planet's magnetic field lines towards the poles, where they excite atmospheric gases, causing them to glow. On Venus, with no significant global magnetic field to funnel these particles, you don't get those spectacular, dancing lights in the sky. Just another little aesthetic pleasure that Venus denies itself, and any hypothetical, very well-shielded visitors. It's a fascinating comparison with Earth. Our magnetic field is a silent guardian, a critical component of our planet's habitability that we rarely think about. It works tirelessly day in and day out, protecting our atmosphere, our climate, and us. Venus, by its lack of such a shield, serves as a stark reminder of how important these invisible forces are. It's another piece of the puzzle that explains why Earth and Venus, despite their superficial similarities in size and origin, have diverged onto such radically different evolutionary paths. One became a haven for life, the other a sterile, irradiated furnace. It makes you appreciate the unseen protections we enjoy here on Earth, doesn't it? That invisible bubble of magnetism, holding the harshness of space at bay. It's a cosmic umbrella, and Venus is out there, perpetually caught in a solar storm without one. So, as you lie there, feeling secure in your bed, in your home, on this well-protected planet, let the thought of Venus's vulnerability to the solar wind deepen your sense of peace. You are shielded. You are safe from that relentless cosmic blast. The Earth's core is working away, deep beneath your feet, generating that protective field, a silent, planetary-scale act of kindness. It's a comforting thought, isn't it? To be so well cared for by the very planet we inhabit. Let that feeling of security envelop you, as we prepare to finally glimpse the surface of this tormented, yet strangely compelling world. We've braved the atmospheric horrors of Venus, contemplated its temporal peculiarities, and acknowledged its unfortunate lack of a protective magnetic hug. For our entire journey so far, the actual surface of Venus has remained an enigma, shrouded beneath that impenetrable eternal blanket of sulfuric acid clouds and dense, hazy CO2. From Earth, and even from orbit around Venus, you simply cannot see its ground with ordinary light. It's a tantalizing secret, hidden from optical view. But human ingenuity and our insatiable curiosity found a way to peek. Not with eyes but with radar. Imagine trying to map the bottom of a very deep, very murky ocean, without ever being able to drain the water or send down a diver with a flashlight. That's the challenge of seeing Venus's surface. Radar, however, doesn't care about clouds. Radio waves at certain frequencies can slice right through that thick Venusian atmosphere as if it were practically transparent, bounce off the solid ground below, and return to the spacecraft, carrying information about the topography. It was primarily NASA's Magellan spacecraft, which orbited Venus from 1990 to 1994, that truly unveiled the face of our twisted sister. Using sophisticated radar mapping techniques, Magellan meticulously peeled back Venus's cloudy veil, giving us our first detailed global look at its bizarre and tortured landscapes. And what it revealed was a world quite unlike Earth in many ways, yet eerily familiar in others. A world sculpted by immense geological forces, primarily volcanism, on a truly epic scale. Forget gentle, rolling hills and verdant plains. The surface of Venus, as revealed by radar, is a testament to fire. Vast volcanic plains stretch for thousands of miles, built up by floods of incredibly fluid lava that erupted over eons. These aren't your picturesque, cone-shaped stratovolcanoes like Mount Fuji, though Venus has some of those too. These are enormous basaltic flows, covering huge swathes of the planet, suggesting periods of cataclysmic volcanic activity that would make Earth's most spectacular eruptions look like mere firecrackers. And the volcanoes themselves. Venus is home to more volcanoes than any other planet in our solar system. Thousands upon thousands of them. From small shield volcanoes and strange pancake-shaped lava domes, called appropriately enough, pancake domes, which are thought to form from very thick, viscous lava, to colossal volcanic mountains that dwarf anything on Earth. Maxwell Montes, the highest mountain range on Venus, located in a continent-sized highland region called Ishtar Terra, named after the Babylonian goddess of love and war, a fittingly Venusian combination, soars to an elevation of about 11 kilometers, nearly 7 miles, above the mean planetary radius. That's higher than Mount Everest. Imagine these gigantic peaks, permanently shrouded in that dim, orange, superheated, high-pressure gloom, their slopes perhaps still dusted with some strange metallic frost that condenses at high altitudes in Venus's bizarre chemistry, possibly metallic sulfides or even tellurium. The radar images also revealed a landscape crisscrossed by complex networks of fractures, ridges, and grooves, evidence of intense tectonic activity. However, Venus doesn't appear to have Earth-style plate tectonics, where large crustal plates drift around, collide, and subduct. Instead, its crust seems to be more of a single, continuous shell, but one that has been stretched, compressed, twisted, and broken by forces from below. Perhaps the intense heat of the interior causes plumes of hot material to rise, pushing and pulling at the surface, creating these unique geological features. There are strange, circular structures called coronae, large, crown-like formations hundreds of miles across, thought to be caused by upwelling mantle plumes that then collapse. They look like giant, geological blisters on the planet's skin. What's perhaps most striking about the Venusian surface is its relative youth, geologically speaking. There are surprisingly few impact craters compared to heavily cratered worlds like Mercury or our Moon. This suggests that the surface of Venus has been repaved or resurfaced relatively recently, within the last few hundred million to perhaps a billion years. One theory is that Venus might experience periodic, planet-wide episodes of catastrophic volcanism, where enormous outbreaks of lava essentially cover over older features, resetting the geological clock. Imagine the entire planet erupting, or a significant portion of it, in a relatively short span of geological time. It's a terrifying yet awe-inspiring image. A planet that literally renews itself through fire. So this is the landscape hidden beneath the clouds. Not a steaming jungle, not a global ocean, but a vast, dry volcanic wasteland, baked to an impossible heat, crushed by an intolerable pressure, and dimly lit by a filtered, sulfurous sun. It's a world that looks like it has been through hell and back several times. There's a harsh, stark beauty to it, if you can appreciate geology on a grand, violent scale. The kind of beauty a blacksmith might find in a freshly forged piece of glowing metal, still radiating intense heat. It's a profoundly alien landscape, yet the processes that shaped it, volcanism, tectonics, impacts, are familiar to us from Earth. Venus just takes them to extremes. It's like Earth's geology turned up to 11 with the safety inhibitors switched off. As you lie there, safely on Earth, with its comparatively gentle geology, its life-sustaining soils, its landscapes softened by water and vegetation, let the thought of Venus's fiery, radar-revealed surface be a distant echo. A reminder of the raw, untamed power of planetary interiors. A world forged in fire and perhaps still simmering. There's a strange sense of completion in finally seeing it, even through the unblinking eye of radar. It fills in a missing piece of the puzzle of our solar system, a dramatic chapter in the story of planetary evolution. And as we let that image settle, we should also remember the brave pioneers who dared to get even closer. We've journeyed to Venus in our minds, peering through its acid clouds with radar eyes to behold its tormented volcanic surface. We've contemplated its crushing atmosphere, its infernal heat, its bizarrely slow, backward rotation. But we are not the first to attempt to unravel Venus's secrets. Long before our imaginary voyage, brave, uncrewed emissaries from Earth, little robotic pioneers, were sent to confront this hellish world directly. And their stories, while often short-lived and ending in predictable, melty silence, are a testament to human curiosity and our relentless drive to explore, even in the face of almost certain doom for our mechanical proxies. These are our robotic sacrificial lambs, offered up to the fiery altar of Venusian science. The Soviet Union in particular had a deep fascination with Venus and mounted an ambitious series of missions under the Venera, meaning Venus in Russian, and Vega programs. These probes were true trailblazers, designed to do what seemed impossible, to penetrate that thick, hostile atmosphere and actually land on the surface. Think about the engineering challenge. You're building a spacecraft that has to survive being dropped into an environment with 90 times Earth's atmospheric pressure, temperatures hot enough to melt lead, and an atmosphere laced with sulfuric acid. It's like designing a diving bell to explore the inside of a blast furnace that also happens to be full of corrosive chemicals. Not exactly an easy design brief. The early Venera missions were a mixed bag of partial successes and outright failures. Some were crushed by the pressure before they even reached the surface. Some overheated. Some just went silent. Each failure, though, provided valuable data, teaching engineers more about the extreme conditions they were up against, allowing them to build tougher, more resilient probes for the next attempt. It was a brutal learning curve, paid for in twisted metal and lost signals. Then came Venera 7 in December 1970. It became the first spacecraft to successfully soft land on another planet and transmit data back to Earth. It survived for a heroic 23 minutes on the surface, sending back temperature readings before succumbing to the Inferno. 23 minutes. That's it. A brief, fleeting whisper from an alien hell. But what a whisper it was. It confirmed unequivocally that the surface of Venus was indeed as hot as previous, more distant measurements had suggested. It was a triumph of engineering and a sobering confirmation of Venus's true nature. Subsequent Venera landers became progressively more sophisticated and, crucially, more robust. Venera 9 and 10 in 1975 not only landed but also sent back the first ever, and still some of the only, actual images from the surface of Venus. These weren't pretty panoramic holiday snaps. They were grainy black and white, though later colorized, images taken through thick, protective quartz windows, showing a desolate, rocky landscape under that dim, orange sky. Flat, angular rocks, some soil, a horizon barely visible through the dense, hazy atmosphere. It was like a glimpse into a primordial, alien furnace. Haunting, stark, utterly uninviting. But for scientists it was gold. Real, visual confirmation of the conditions on the ground. These landers were built like tiny, armored bathyspheres. They had to be. They carried sophisticated cooling systems to try and keep their electronics from frying for as long as possible. Some had little arms to test the soil composition. They measured pressure, temperature, wind speed, which surprisingly is quite low right at the surface, despite the furious winds higher up in the clouds. Each one was a suicide mission by design. They were sent to gather as much data as they could in the few precious minutes, or perhaps an hour if they were exceptionally lucky, before the crushing heat and pressure inevitably claimed them. Imagine the engineers and scientists back on Earth, huddled around their consoles, waiting for that faint signal from across tens of millions of miles. The tension, the hope, and then the torrent of data, pressure readings, temperature spikes, perhaps a blurry image appearing line by line. And then, inevitably, the signal weakening, becoming garbled, and finally, silence. The little probe, their creation, had done its job and then, quite literally, melted or been crushed into the Venusian landscape. A bittersweet victory. A robotic hero's end. Even the American pioneer Venus multi-probe mission in 1978 sent 4 probes, 1 large, 3 small, crashing through the atmosphere. None were designed to survive landing, but one of the small probes actually did, unexpectedly, and continued to transmit data from the surface for over an hour. A testament to over-engineering, or perhaps just Venus being momentarily distracted. These missions, these brief, fiery encounters, painted a progressively clearer picture of Venus. They confirmed the extreme temperatures and pressures, analyzed the atmospheric composition, and gave us our first tantalizing glimpses of its surface before Magellan's radar mapping. They were acts of incredible scientific bravery, pushing the boundaries of what was technologically possible. Each little probe that perished on Venus was a martyr for planetary science, its demise a data point that helped us understand our twisted sister a little better. It makes you think about the nature of exploration, doesn't it? We can't go there ourselves, not yet, perhaps not ever to the surface. So we send these robotic extensions of our senses, these intrepid, uncomplaining proxies. They face the horrors for us, silently screaming their data back across the void until they can scream no more. There's something poignant about it. A little bit of human ingenuity, a spark of our curiosity, lying broken and silent on the plains of Venus, having briefly touched the face of an inferno. So, as you lie there, comfortable and safe, spare a thought for those brave little robots. The Veneris, the Vegas, the Pioneer probes. They ventured into the solar system's most inhospitable planetary surface so that we could learn. Their legacy is the knowledge we have today, the knowledge that allows us to paint this vivid, if terrifying, picture of Venus. They were our eyes, our thermometers, our pressure gauges, in a place we could never survive. And in their silent sacrifice, there's a story of human endeavor that is, in its own way, as awe-inspiring as the planet they explored. We've journeyed with the robotic martyrs, felt the phantom touch of Venus's extreme environment, and peered through its cloudy veil to the fiery volcanic plains below. We know Venus now as a hellscape, a planetary scale warning label in our solar system. But the question that often lingers, a faint, wistful sigh in the cosmic narrative, is, was it always this way? Or is Venus the ghost of a world that might have been, a world that once held the promise of something gentler? Did Venus once dream of oceans, of blue skies, before it took its catastrophic wrong turn? This is where science meets a touch of melancholy speculation, a what-if story on a planetary scale. The current thinking, as we touched upon when discussing the runaway greenhouse effect, is that early Venus, billions of years ago, could have been a very different place. It might have been much more Earth-like. Imagine a young Venus, perhaps 3 or 4 billion years in the past. The sun was a little fainter then. Venus, being closer to this dimmer, younger sun, might have received a similar amount of solar energy as Earth does today. It's plausible that early Venus had liquid water on its surface. Perhaps vast oceans, shallow seas, rivers, and lakes. Picture it, a water world shimmering under a younger sun, clouds of actual water vapor drifting through its skies. A blue Venus, if you will. If there was liquid water, then the conditions for the origin of life as we understand it might have existed. We don't know if life ever did arise on Venus, and if it did, whether it was snuffed out by the later climatic catastrophe, or if some incredibly resilient, bizarre form managed to retreat to some niche environment, like hypothetically certain layers of the atmosphere where temperatures and pressures are more clement, though still doused in sulfuric acid, a long shot, but a fascinating one for astrobiologists. But for a time, perhaps for hundreds of millions, maybe even a billion or 2 years, Venus could have been a habitable world. A second cradle of life in our solar system. It's a tantalizing, almost romantic thought, isn't it? Earth and Venus, 2 sister planets, both potentially teeming with the first stirrings of biology. Perhaps they exchanged material via asteroid impacts, seeding each other with the building blocks of life. It paints a picture of a much more vibrant, hopeful young solar system. So what happened to this hypothetical paradise, this blue Venus? The leading theory, as we've discussed, is the runaway greenhouse effect, kicked into high gear by Venus's proximity to a gradually brightening sun and its own geological processes. As the sun's output increased over eons, Venus would have gotten warmer. More water would have evaporated. Water vapor, a potent greenhouse gas, would have trapped more heat. This positive feedback loop, potentially without the mitigating geological and biological cycles we have on Earth, like plate tectonics efficiently burying carbon, or widespread life drawing down CO2, would have eventually pushed Venus past a tipping point. The oceans would have begun to boil. All that water vapor would have flooded the atmosphere, accelerating the heating catastrophically. High in the atmosphere, solar UV radiation would have dissociated the water molecules, with the light hydrogen escaping to space, and the oxygen reacting with surface rocks or other gases. The water was lost irretrievably. And as the planet dried out and heated up, massive amounts of carbon dioxide, perhaps locked in rocks or released by planet-wide volcanism, would have accumulated in the atmosphere, creating the dense, superheated, CO2-dominated inferno we see today. It's a tragic story if you think about it from a planetary perspective. A world that might have had it all, oceans, perhaps even life, succumbing to a climatic death spiral, transforming into its own evil twin. It's like watching a beautiful garden wither, crack, and burst into flames, leaving behind only scorched earth. The evidence for this wetter past is circumstantial but compelling. For instance, the ratio of deuterium, a heavy isotope of hydrogen, to regular hydrogen in Venus's atmosphere is much higher than on Earth. Since lighter hydrogen escapes to space more easily than heavier deuterium, this high deuterium to hydrogen ratio suggests that Venus once had significantly more water, most of which has since been lost, leaving behind a higher concentration of the heavier isotope. It's a ghost of what might have been. A poignant reminder of planetary fragility. When we look at Venus now, we're not just seeing a hostile world, we might be seeing the desiccated, superheated corpse of a once habitable planet. It adds another layer to its already complex and unsettling character. Not just a monster, but perhaps a fallen angel. This idea of a lost Eden next door makes Earth's own story all the more remarkable. Our planet has, so far, managed to navigate its own long history, through ice ages and warm periods, asteroid impacts and supervolcanoes, and maintain conditions suitable for life for billions of years. It's a delicate dance, a complex interplay of geology, atmosphere, oceans, and life itself, that has kept Earth on the right side of the habitable zone. Venus serves as a stark example of what happens when that dance falters, when the feedback loops turn destructive. So, as you lie there letting your mind drift, contemplate this cosmic, what if? Imagine that young, blue Venus, full of potential. And then picture its slow, inexorable transformation into the inferno we know. It's a grand, tragic opera playing out on a planetary stage. There's a certain melancholy beauty in this story, a sense of cosmic loss. But it also throws into sharp relief the preciousness of what we have here on Earth. Our blue oceans, our breathable air, our temperate climate. These are not givens. They are the result of a long and sometimes precarious planetary journey. Let the story of Venus's lost past not be a source of sadness, but a profound reminder to cherish the present, to appreciate the incredible, ongoing miracle of a habitable Earth. It's a humbling thought, one that can, paradoxically, bring a deep sense of peace and gratitude. A gratitude for the resilience of our own world, and a quiet acknowledgement of the cosmic dramas that play out all around us, shaping the fate of worlds. We've delved deep into the fiery heart of Venus, explored its hostile surface, its crushing atmosphere, its peculiar rotation, and even mourned its hypothetical lost oceans. We know it, intellectually, as a truly dreadful place, a cosmic inferno next door. And yet, step outside on a clear evening, just as the sun dips below the horizon, or in the quiet moments before dawn, and you might see her. A brilliant, steady, impossibly beautiful point of light, hanging in the twilight sky. The evening star. The morning star. Venus. This is perhaps one of the greatest and most poetically cruel deceptions in our solar system. How can something that appears so serene, so pure, so utterly captivating from our earthly vantage point, be in reality such a monstrous, inhospitable horror? It's the ultimate cosmic catfish, luring us in with its radiant beauty, only to reveal a personality forged in hellfire. For millennia, before we had telescopes powerful enough to resolve its disk, before we sent our robotic probes to their fiery doom, Venus was a mystery, an object of wonder and reverence. Ancient civilizations across the globe observed its majestic passage through the heavens. The Greeks and Romans named it after their goddess of love and beauty, Aphrodite, Venus. The Maya, meticulous astronomers, tracked its cycles with incredible precision, incorporating it into their calendars and their cosmology. It was a beacon, a celestial marker, often associated with deities with omens with the very rhythm of time. And you can see why. There's a certain pristine quality to its light. Unlike stars, which are distant suns and therefore twinkle as their light passes through Earth's turbulent atmosphere, Venus, being a planet reflecting our own sun's light, shines with a steady, unwavering brilliance. It can be so bright, in fact, that it's sometimes visible in broad daylight, if you know exactly where to look. It can even cast faint shadows on a very dark, clear night. It outshines every other star or planet in our sky, save for the moon and, of course, the sun itself. This sheer visual splendor, this calm, bright presence, is what makes the truth of Venus so jarring, so ironic. It's as if the universe decided to play a practical joke, packaging its most nightmarish planetary environment in the most alluring, beautiful wrapping paper imaginable. Here, the cosmos seems to say with a wink, look at this exquisite jewel. Isn't it breathtaking? Now, let me tell you about the lead-melting temperatures and the flesh-dissolving acid rain. It's a profound lesson in not judging a book by its cover, writ large across the heavens. It speaks to our human tendency to project our own desires, our own ideals of beauty and peace, onto the unknown. We saw a radiant light and imagined a radiant world. We saw a sister planet and hoped for a kindred spirit. Reality, as it so often does, had other, far more brutal plans. This deceitful gleam of Venus also highlights the vastness of space and the limitations of our senses. From millions of miles away, all the turmoil, all the crushing pressure, all the searing heat, all the corrosive chemistry, is entirely invisible. It's reduced to a single lovely point of reflected sunlight. It's a reminder that what we perceive is often just a tiny fraction of reality, a filtered, simplified version. The universe is full of wonders that are beautiful from afar but deadly up close. Nebulae, supernovae, even our own sun, all magnificent, all lethal if you get too intimate. Venus just happens to be the most prominent example in our own celestial backyard. There's a certain dark humor in it too. The goddess of love and beauty presiding over a realm of such utter desolation and hostility. It's as if the universe enjoys a good paradox, a bit of cosmic irony. You humans and your pretty myths, it seems to chuckle. Let me show you what beauty really looks like when it's been through a runaway greenhouse effect. But even in this deception, there's a strange kind of comfort to be found, especially as we seek relaxation and sleep. The beauty of Venus in our sky is still real. It is breathtaking. The fact that the planet itself is a hellscape doesn't diminish the loveliness of that distant point of light. It just adds a layer of complexity, a knowing wryness to our appreciation. So, the next time you see Venus gracing the twilight, allow yourself to be captivated by its beauty. Admire its steady, silver glow. And then, perhaps, a little smile might play on your lips as you remember the fiery, acid-drenched truth it conceals. It's like being in on a cosmic secret. You see the beautiful facade, but you know what's really going on beneath the surface. And that knowledge, that understanding of the stark contrast between appearance and reality, can be strangely grounding. It puts our own earthly concerns into perspective, doesn't it? We worry about so many things, but at least our planet isn't actively trying to melt, crush, and dissolve us while looking like a celestial supermodel from next door. There's a comfort in that. A profound, if slightly morbid, comfort. Let the image of that beautiful, deceitful evening star hang in your mind. A pinpoint of serene light, hiding a universe of chaos. It's a perfect symbol for the kind of relaxation we're seeking here. A peace that comes not from ignoring the harsh realities, but from acknowledging them, understanding them, and then choosing to find our calm despite them or even because of them. Venus, the beautiful lyre, can, in her own strange way, guide us to just that kind of ironic, knowing peace. We've journeyed far with Venus, our radiant yet terrifying celestial neighbor. We've peeled back her pearly, acidic veil, felt the phantom sensations of her crushing embrace and fiery breath, navigated her bizarre temporality, and even mourned the ghost of her potentially habitable past. We've acknowledged the bravery of our robotic explorers who dared to touch her infernal surface, and we've marveled at the beautiful, deceitful gleam she presents in our night sky. So, what's the takeaway from all this? What lessons does this twisted sister, this cosmic cautionary tale, offer us as we drift towards sleep? Well, Venus, in her magnificent awfulness, is perhaps the universe's most eloquent, if brutal, teacher on the subject of appreciating what you've got. She's a sibling whose harsh life lessons are delivered with the subtlety of a planetary scale furnace. The first and most obvious lesson is gratitude for the sheer, improbable luck of Earth. Every terrifying detail we've explored about Venus, the runaway greenhouse effect, the lack of water, the suffocating CO2 atmosphere, the acid rain, the crushing pressure, the lead melting temperatures, the absent magnetic shield, serves as a stark counterpoint to the conditions on our own world. Venus is the universe holding up a cosmic mirror and saying, "See this? This is what happens when things go really wrong. Now look at your own little blue marble." Feeling a bit more appreciative of its breathable air, its liquid oceans, its comfortable temperatures, and its generally non-homicidal geology. It's easy to take Earth for granted. We live here. Its life-sustaining qualities are the baseline, the norm against which we measure everything. But Venus forces us to confront the reality that this norm is actually an extraordinary exception. Habitable worlds, at least as far as we know, are rare and precious jewels in the vast cosmic darkness. Venus, by being so spectacularly uninhabitable while being so superficially similar to Earth in size and origin, hammers this point home with brutal efficiency. It's like having a sibling who made all the worst possible life choices, and whose disastrous existence serves as a constant, if grim, reminder to count your own blessings. "Well, at least I didn't end up like Venus," Earth might say with a weary sigh. This perspective can be incredibly calming, paradoxically. When you contemplate the sheer, unadulterated hostility of a place like Venus, your own everyday anxieties and stresses can shrink in comparison. Worried about a deadline? At least you're not worried about being simultaneously crushed, cooked, and dissolved. Annoyed by traffic? At least the air you're breathing isn't 96.5% CO2 laced with sulfuric acid. It's a dark sort of humor, perhaps, but it's effective. Cosmic perspective can be a wonderful antidote to terrestrial angst. Venus, in her fiery torment, offers us that perspective in spades. Another lesson from our Venusian voyage is a deeper understanding of fragility. Planetary environments are not static, they evolve. They can change, sometimes dramatically, sometimes irrevocably. Venus likely wasn't always the Inferno it is today. It may have had a more temperate past, perhaps even oceans. Its story is a sobering reminder that a planet's climate is a complex, dynamic system, and that tipping points exist. While Earth isn't about to turn into Venus tomorrow, the tale of our sister planet underscores the importance of understanding and respecting the delicate balances that maintain our own world's habitability. It's a subtle, cosmic nudge towards responsible stewardship, whispered from a world that lost its way. Furthermore, Venus teaches us about the deceptive nature of appearances, as we discussed. That beautiful evening star, so serene from afar, hides a violent, chaotic reality. It's a universal truth, really. Things are often not what they seem on the surface. This can be a valuable lesson in cultivating a more critical, discerning eye, not just in astronomy but in life. It encourages us to look deeper, to question, to seek understanding beyond the superficial. And, perhaps, to be a little more forgiving of things or people that aren't quite as perfect as they appear from a distance. After all, if a whole planet can be that misleading, what chance do the rest of us have? And finally, there's a lesson in acceptance, albeit a rather grim one. Venus is what it is. It's a product of cosmic forces, planetary evolution, and perhaps some bad luck. There's no changing it. There's no fixing Venus. Our understanding of it doesn't alter its reality. There's a certain peace to be found in that kind of radical acceptance of things as they are, especially things so far beyond our control. We can study it, learn from it, be awed and terrified by it, but ultimately we must accept its nature. And in accepting the harsh realities of the universe, like the existence of a place as extreme as Venus, we can perhaps find it a little easier to accept the smaller, more manageable harsh realities of our own lives. So, as you lie there, letting these thoughts drift through your mind, let Venus be your unlikely guide to gratitude, perspective, and a uniquely ironic form of peace. Her story, full of fire and brimstone, paradoxically paves a path to a deeper appreciation for the gentle, life-sustaining embrace of Earth. She's the ultimate, it could be worse scenario, and in that there's a strange, soothing power. A sibling's harsh life lessons indeed, but perhaps, in their own twisted way, just what we need to hear to truly relax and let go. And so, our journey to Venus, Earth's spectacularly twisted sister, draws to a gentle close. We have peered through her acid-laced veil, imagined the crushing weight of her atmosphere, felt the phantom kiss of her lead-melting heat. We've pondered her sluggish, backward days that outlast her years, and considered the lonely, unprotected vigil she keeps against the relentless solar wind. We've sifted through the ashes of her hypothetical watery past and saluted the brave doomed robots who dared to touch her fiery skin. We've even admired her deceitful beauty as she hangs, a serene jewel in our twilight sky. It has been, in its own peculiar way, a strangely soothing exploration of a truly terrifying place. How can this be? How can dwelling on such an infernal landscape, a planetary catalog of everything that can go catastrophically wrong, possibly lead to a sense of peace, of relaxation, of readiness for sleep? It's one of the beautiful paradoxes of the human mind, and perhaps one of the core secrets of this cosmic bedtime story. There's a profound serenity to be found in understanding, even when that understanding encompasses things that are harsh, indifferent, or downright hostile. Venus, in all her magnificent terribleness, is a known quantity, at least to a degree. Science has pulled back the curtain, revealing the mechanisms of her madness, the runaway greenhouse effect, the atmospheric composition, the geological history. And in this knowledge there is a certain power. Fear often thrives in the unknown, in the shadows. By shining a light, even a dim, orange, Venusian-filtered light, on these cosmic extremes, we domesticate them somewhat. We bring them into the realm of the understood, and therefore the less immediately threatening to our own sense of equilibrium. Moreover, contemplating Venus serves as a potent exercise in perspective. Our daily worries, our anxieties, the stresses that cling to us like cosmic dust, they tend to diminish, to lose some of their sharp edges, when placed alongside the sheer, overwhelming scale of Venus's environmental challenges. It's hard to get too worked up about a misplaced set of keys or an awkward email when you've just spent an hour mentally navigating a world where the air itself is a crushing, corrosive, superheated poison. It's the universe's way of saying, hey, relax. Could be so much worse. You could be on Venus. And in that slightly absurd, darkly humorous comparison, there's a genuine release, a letting go. There's also a strange comfort in insignificance when framed correctly. Venus is a testament to the vast, impersonal forces that shape the cosmos. It wasn't designed to be hostile to us. It simply is a result of physics and chemistry playing out on a planetary scale over billions of years. Its fate was sealed long before humanity even existed. Recognizing our own smallness, our own fleeting presence in the face of such immense cosmic dramas, can be incredibly liberating. If the universe can churn out something as spectacularly awful as Venus without any particular malice, then perhaps our own small struggles are not the center of existence. Perhaps we can afford to lighten up, to not take ourselves or our problems quite so seriously. And finally, there's the simple, profound gratitude that arises from this cosmic comparison. By exploring the Inferno next door, we return to Earth with fresh eyes. We see, perhaps for the first time in a while, the miracle of breathable air, the wonder of liquid water, the gentle embrace of a stable climate. Venus, by showing us the extreme, illuminates the preciousness of our own relatively benign home. This gratitude is a soft pillow for the mind, a warm blanket of appreciation that can soothe us into a state of quiet contentment. So, as we draw the curtain on our Venusian voyage, let the image of that fiery, tormented world fade gently from your mind. Or, if it lingers, let it be as a distant, glowing ember, a reminder of the vast and varied tapestry of the cosmos, with all its beauty and all its terror, all its wonders and all its harsh truths. Let the story of Venus be not a nightmare, but a strangely effective lullaby. A tale of a world gone wrong that paradoxically helps us feel that right here, right now, in the safety of our own beds, on our own remarkably hospitable planet, things are profoundly, wonderfully, peacefully right. The universe is vast and full of surprises, some delightful, some Venusian. But tonight you are here, safe, breathing easily. And as the silence of space gently enfolds your thoughts, let the extreme story of Venus simply melt away, leaving behind only a sense of calm, a wry smile, and the gentle invitation to drift into a deep and untroubled sleep. And so, the tale of Venus, our brilliant and brutal sister, fades into the soft static of the cosmos, like a distant radio signal finally succumbing to the immense, quiet indifference of space. Let her fiery plains and acid clouds, her crushing pressures and lead-melting heat, recede now, becoming just faint echoes in the vast library of your mind. They have served their purpose, these stark realities, these uncomfortable truths. They have shown you the extreme so that you may better appreciate the gentle. They have whispered of cosmic terrors, so that your own small haven might feel all the more secure. As you lie here, suspended in that peaceful space between wakefulness and dream, feel the immense, silent turning of our own Earth. Feel its quiet strength, its steadfast protection. Unlike Venus, it asks so little and gives so much. The air you breathe, the gentle gravity that holds you, the magnetic shield that guards your slumbers from the harsher whispers of the sun. These are gifts, offered freely, continuously by a planet that, against considerable cosmic odds, got it wonderfully, beautifully right. The universe, in its grand, sprawling and often absurd narrative, contains multitudes. It holds the breathtaking beauty of a spiral galaxy and the incomprehensible density of a black hole. It cradles the delicate miracle of life on Earth and casually cooks its next-door neighbor into a sterile inferno. It is vast and wild and largely unconcerned with our opinions or our comfort. And yet, within this grand, indifferent scheme, you have found this moment. This quiet pocket of peace. This safe harbor for your mind. So let go of the day. Let go of Venus. Let go of everything but the gentle rhythm of your own breath. Each inhale, a soft wave of calm. Each exhale, a release of any lingering tension, any thought that does not serve your rest. The universe will continue its magnificent, chaotic dance, its creation and destruction, its beauty and its horror, all without your supervision. Tonight, your only task is to drift, to float, to sink into the deep, dark, velvety comfort of sleep. Sweet dreams, cosmic voyager. You've earned them. After all, you've just been to hell and back and you didn't even have to leave your bed. Rest now. Rest deep.